All right, guys, let's get started here. I gave Seth mine, so I gotta.
Broke a fence.
I drove through a fence, Mom.
So I want to go over the one or two examples from 12. I can see a couple of you guys are kind of already figured that out. That's great. So today I'm going to go over some stuff from 12 and some stuff from the next few problems on 13 that involve square roots. And yeah, we'll go from there.
I have 13.
So, little opening question here. What would you get if you had x to the third power raised to the fourth power? What would that equal? X to the, you might ask, is okay, I know it's either 7 or 12, right? Because I know either you add them here or you multiply them. The answer in this case is you multiply them. The reason for that is actually very simple. You can figure that out just by knowing what an exponent means. So like what I'm talking about is x cubed means x times x times x. So if that thing is raised to the fourth power, imagine 4 copies of that. I guess you don't have to imagine, I'll draw it for you. 1 copy, 2 copies, 3 copies, 4 copies. And then if you go, oh, I know what multiplication is, that's the same as saying 3 times 4. So the moral of the story there is if you have, say, x to some power raised to another power, you can you multiply the powers. Now, for you deep thinkers out there, you might realize that logically speaking, the argument makes perfect sense for integers, but it's definitely not obvious that this would also hold true for like if a was like, say, 3/4 and b was 2/5, right? It's not obvious, but it does. You'll have to take my word for it for now. Maybe if you down the road in your learning, you can prove that that's true. But okay, one more thing. What does it mean if you say, let's say I said, oh, I got x to the 3/5 power. What does that mean? 3/5 power. It's going to be, there's 2 ways of rewriting it. You can think of this as being the 5th root of x cubed, or you could think of it as the 5th root of x cubed like that. Those are equivalent expressions. Is everyone okay with that? Does that make sense? Let me fix that real quick. Before I move on here, are there any confusion? Any questions? Okay, great. Okay, so then you might be wondering, well, what does that have to do with like answering a question like this? How does that help us? So let me generalize that real quick. This is the same as saying, if I have x to the, say, a over b power, that's the same as the bth root of x today. So we just put a box around that. We're going to use those 2 ideas to solve this. So what am I going to do to both sides of the equation? Not multiply, we're going to raise both sides to the 3/2 power. So then why? Why do that? Well, this property tells me that that these exponents are going to multiply each other, right? Well, what's 2/3 multiplied by 3/2?
X.
Well, that's what's going to be left over, yeah. But that times that is 1, and so what you have left over is x to the 1 power. That's kind of what your goal is when you're solving an equation, right? Is to just get a simple x by itself. Nothing multiplied by it, nothing dividing it, no power. So now you've got this. That certainly is like a valid answer, but we can simplify that number. There's an easier way to write the number 9 to the 3/2 power. So what root is it? The two, notice it's the bottom number tells you the power of the root. So the 2th root, but you typically don't write the 2, you just write the square root. But it's the square root of 9 cubed. What's the square root of 9? 3. 3 cubed is 27. So there's one more kind of a nuanced thing here. Right. You're going to ask yourself in all these questions, do I need to say plus or minus? And my recommendation for figuring that out is to look back at the original equation. So the original says this, right? So this number here is getting squared because the top number tells you like what power it's getting raised to. So if this is getting squared, that tells you that x could be a negative number and it would still work out, right? So what that tells you is you put a plus or minus. So there's actually 2 solutions to this question. Yes.
You have to go like take the root and then the power, right? You can't go power and then root.
You could.
Oh,
So like you can go, those are equivalent. Now, most of the time though, like here, I mean, which is easier? Take the square root of 9 then cube it, or cube 9 and then square root it? Obviously, it's much easier. But I think there's one on there where
Yeah.
it makes a lot more sense to do the power first before the root. I'm sure that's what you're talking about, right?
Mm.
Oh, one last thing. Who is that?
Birdie.
Mr. Birdie. It's our avian friend. Okay? So I just want to show you a little graphical perspective here. The question of when does Mr. Birdie hit a y value of 9? That's another way to phrase this question. This will give you some more insight maybe into why there are 2 solutions. Because a birdie, if you picked a certain y value and said, when does that birdie hit a y value of 9, there'd be 2 answers to that question. Okay? And they'd be symmetrical across the y-axis. You feel okay about that?
Mm-hmm.
Let me cover, let's just front load this, then we'll have some class time to work. How about that? Sound good?
Mm-hmm.
Should I go over one more of these, or you guys feel like you got it? Thumbs up, anyone? Okay, sweet. So 13, so if you look at 13, 14, and 15, and 16, you'll notice that's a decent chunk of problems that all involve square roots. And don't worry, it's not 4 pages of the exact same type of question. They kind of vary. So, they get kind of harder as you go. The first one's actually fairly simple. We'll do 13A.
What did he say? Plus or minus?
Okay, what's the first thing we should do here? What's our first step? Subtract
It's
1. You don't have to do this, but I'll do it for this first example. Subtract 1 from both sides. Now what?
Divide by 3.
Divide both sides by 3. Okay, now here, there's 2 mistakes that are very common. They're pretty understandable mistakes. I want to point them out so you kind of try to avoid them. The first mistake people make is they just square root here. But they say, oh, the answer is 2. But you go, wait a second, that's not right because the square root of 2 is not 4. So what do you really want to do here instead of square root? You want to square both sides, right? So you square both sides. So you get x is 16. The other mistake people make is they put a plus or minus there. Again, understandable because you're dealing with square roots and squares and stuff, but think about the answer. I mean, negative 16 can't be an answer because you try to plug negative 16 in there, you'd be like, well, you can't square negative 16 to begin with, so that's going to be a problem. Long story short, the answer is just the number 16. That's it. guys feel okay about that? Let's do one or two more. Let's look at C. A similar structure. Okay. Bananas. How many, let's think of that as a banana, this whole thing.
Monkey explanation.
How many bananas? There's 3 bananas. How many bananas are over here? Okay, so let's subtract a banana from both sides. So subtract 1 banana. 3 bananas minus 1 banana makes 2 bananas. Equals, on the right side, what's left over is 3. So I bring up the bananas because it's just emphasizing the idea that you can pick an expression inside the equation and kind of identify that as like a chunk of information and say, that's the thing, I'm going to subtract that thing from both sides. It doesn't have to be a single, like in this one, we're, just subtracting a number from both sides, dividing both sides by a number. You can subtract an entire expression from both sides. Then what?
Then you do the
Divide both sides by 2. Then what?
Then you square.
Square. So the square root of a thing squared
The thing.
will just be that thing, assuming that it's non-negative, of course. By the way, something to look out for in the near future is if we do a bunch of math and x, let's say x turned out to be like -7, you'd be like, wait a second, x can't be -7. That wouldn't even be allowed to get plugged in there. And that would tell you that your equation had no solutions. So in this case, though, we're going to get something nicer. What do you get if you square 3 halves?
9 quarters.
9 quarters. Almost done. How many quarters is a 1? 4 quarters. So add the 4 quarters over to be with the 9 quarters, and you get the answer, which is 13 quarters. So many quarters, I know.
That's like-
Rich, that rich life.
It's like a little over $3.
So, yeah, there you go. That's all there is to it. Notice, everything we're doing is just, it's the same stuff you did in think way back to the first algebra you ever saw back in middle school. Yeah, it's more complicated, but it's still that same central idea of you can do whatever you like to the equation as long as you obey the order of operations correctly. And whatever you do to the left side of the equation, you also do the exact same thing consistently to the right side of the equation. So in this case, it happened to be subtracting an expression, then division, then exponentiation, and then addition. So there you go. So that page of questions are all kind of similar in that same way. I want to go over 2 more examples here, at least 2 more. We'll do 14, 14B. Looks kind of interesting.
You got 5 for that?
I like these ones.
Yeah, these ones are.
You like them?
Yes. They're simple.
If
You
monkey
just-
have 10 bananas,
you just
monkey
do
rich.
it.
Monkey have 0 bananas, monkey 4. If 4 monkey 10 bananas, both monkey worthless bananas. Banana have no worth. If both
Banana
monkey have
inflation.
$10. Banana.
Banana inflation.
One monkey, 10 bananas.
That's why
Other
you
monkey,
should
0 bananas. If both monkey 10 bananas, banana worth nothing.
That's why you increase taxes to deal with banana inflation.
Just print
And
more
then
money.
while you decrease taxes again, you can.
How can we be poor? Just print more money.
You can though.
Print more money.
Yeah.
No other change. Just print more money.
Okay.
Money printer go bird.
This question has a surprisingly simple solution. It doesn't look like an easy question when you first look at it, right? So the question is, is there a number out there where if you triple its square root and then subtract 5 divided by its square root, you get 0?
Yeah.
Which there is. It turns out in this case, if we add this guy over to the right-hand side, all right. What should we do to both sides of the equation that would multiply by the square root of x? Yeah. Because I would look at this fraction and say, I'd be much happier here if there wasn't a fraction there, right? You'd say, oh, it'd be much better if I just multiplied by root x with the intention of just canceling Bovansely's right there, right? Of course, if I multiply the right side of the equation by root x, I also have to multiply the left side by root x. So now what happens? Well, what's root x times root x? Just x. Again, assuming that x is not negative. Over here, we just got 5, and you go, wait, wow, that one step turned it from a scary equation into a very simple equation. So the answer here would be just 5/3. Not too bad, right? So there's the common theme here on 14 is almost all the equations there have the same kind of structure, as I'm sure you can kind of tell by looking at them. They all have square root of something showing up 2 times in the equation. Except f's a little bit different, but I think you guys will figure that out without too much trouble. So one last thing to cover, then we'll have some work time here. Something more challenging. 15a.
A is in
Then,
Good one. That's good. Very clever. All right, so so the question here is there a number out there? Does there exist out there in the world of numbers
probably not.
where is there a number that if you add it to its own square root, you just get 1? Is it possible?
yes,
Maybe. Some of these have no solution, by the way, just so you know.
Oh,
I've decided this one exists.
You decided this one exists? Yeah. Okay, that's fair enough.
every number exists.
There's actually a strong argument for why the answer has to exist, because if you think about x plus root x, like if x was 0, if you graph this like a function, if x was 0, you'd have 0. And does it make sense how as x gets bigger, this quantity just gets bigger and bigger somehow? So yeah, it's got to hit 1 eventually. There must be some point at which it hits 1. And we know there's going to be one solution. And I don't see any reason why it should double back on itself. So there's probably only one solution, not 2 solutions. Something to keep in the back of your mind. Okay. Who's got an idea of what our first step could be to answer this question? Anyone?
Square.
Let's look at that. What happens? Okay, that's a good idea, but watch what happens. Square both sides. You're gonna have. Don't copy this down. This is gonna end up being not quite the right way to go. You get x squared plus 2x root x plus x equals 1. You go,
No, thank you.
Yeah, no. I'm sorry.
As you should be.
Yes, very good. So that squaring both sides is a really good idea, but it's just a little bit early here.
Yeah.
What you want to do first, the idea here, guys, is whatever item in your equation is being square rooted, you want that thing to be by itself when you square both sides. Because as you saw, if it's not by itself, it ends up popping up in other terms. So you want to just make sure that it's isolated. So now let's square both sides. Okay, so squaring root x gives me x. Squaring this gets me 1 squared minus 2 times 1 times x. Is everyone okay with that? And how do I solve something like this?
Bring the
It's
You want to get everything by itself, right? Or everything on one side. And then hopefully factor, but we maybe have, on this one, we maybe have a feeling that it's not factorable because if there had been a rational
Okay,
solution to this, then it probably would have been obvious, right?
Yeah.
Like if this had had an answer like 1 or like a half or something, we probably would have spotted it already, most likely, but maybe not. In any case, that's not factorable, right? We can tell her. Maybe a little trial and error. You go, well, yeah. There's no two rational numbers that are going to work out. So, what's probably our best option when you have something like this? Quadratic formula. If this number was even, I'd probably just do complete the square. I know many of you guys are like, April. Trying to stay awake there. This is like highly hypnotic stuff here. Okay, so quadratic formula, remember that one is, there's my quadratic formula. So it's going to be the opposite of b, which would be 3 plus or minus the square root of b squared, which is 9, minus 4 times a times c. You gotta be really careful with your c value there, because if that's negative, make sure it's negative there, but it's positive. So all over 2a. Now, maybe some of you guys will pick up on why there's a slight issue here, or maybe I should say it's not really an issue so much as, oh no, it is, sorry. Talking myself in circles here. What's the issue here?
plus or minus when there can only be one.
Yeah, exactly. Nice job. So we already said a few minutes ago that there can only be one solution to this. There's only one number logically that can be the answer. So is it 3 plus root 5 over 2, or is it 3 minus root 5 over 2? So I'll show you how to know the answer to that. It's a pretty simple trick. Look at this, or actually what I should say is look at the second step you had. This, and if you think graphically about what that would look like if you solved it graphically, which would be, we know what that looks like, right? Please, fingers crossed. Square equations. Okay. And then we know what this, so let's say this is the point 1, 1. And then you know what the graph 1 minus x looks like. I kind of missed my mark there, but
It's positive.
you know what Michael J. Knudsen would say? Well, here's the thing though. 3 minus root 5 is also positive. So this one's extra tricky because 3 plus root 5 is positive, and so is 3 minus root 5. But we know that the answer is less than 1. But 3 plus root 5 over 2 would be bigger than 1. So does that make sense? This might not be obvious, but 3 plus root 5 over 2, this number is bigger than 2, right? So 3 plus a number bigger than 2 is like 5 and change. So you know that this number here is certainly bigger than 1. But 3 minus root 5 over 2 is what you're looking for. So, that's kind of a beautiful number. If you, no, Emily, don't agree. No, come on. It relates the smallest 3 primes. Beautiful. 3 smallest primes, 2, 3, and 5. And then also this funky relationship between those primes tells you the answer to this. I think it's a pretty fundamental question. What number plus its own square root makes 1? Okay, never mind. Forget it. Oh man, okay, I'm just gonna, there you go, there's your video, there's your example for, that example will apply to 15 and 16, okay? All those questions, the name of the game, I just want to reiterate one last time, the name of the game is get that square root term by itself on one side of the equation, then you square both sides, and then you have to make you gotta make a careful consideration of one of your answers is gonna be extraneous. It's not gonna be a legit solution, so. All right, end the stream here. Thanks for the million bits.